Welcome back, dear students. I hope you all are doing well. Now, in today's session, we will be discussing about file concepts, file management, access methods, and so on. So let's get started. First, we'll discuss file concept. A file can be considered as a contiguous logical address space. So here we are assuming a file to be contiguous logical address space. It has got some types. When we say a particular type of file, say for example image file type, you have text file type, right? So whatever kind of file it is, it has got some type. For example, JPG, you have TXT, you have docs. So these are various types of files, and it has got some data as well as program. Now data can be numeric, character, or binary. So data can be of any type. It can be numeric type, it can be character, or it can be binary, and it has got some code which we are calling it as program. A file structure can be a sequence of words or bytes if the file is unstructured. So we are calling the file structure. If it is none, that is unstructured, then file consists of sequence of bytes or words. If a file is a simple record structure, it includes lines and it has got some length. Now the length of the file can be either fixed or variable. In case your file structure is of type complex, then it is including a formatted document. In a particular format, the file is being created, and this file is relocatable load file. Now we can simulate the last two, that is the formatted document and relocatable load file, with the first method, that is by just simple record structure, just by inserting appropriate control characters. Now a file structure is decided by the operating system and the program. A file is associated with some attributes, namely it has got name, identifier, type, location, size, protection, data, and user identification. Every file must have name in human readable form. This is just for the users to get some idea about the file content. That's why it is kept in human readable form. A file has got its identifier, that is a unique number which identifies file within the file system. A file must have its type. As I said, there can be any type of file, like image file, like you have got some video file, or you have some text files. Okay, so it has got some type which is needed for the system that support different types. Location is a file attribute that points to the file location on the device where it is stored. Size is an attribute that gives you an idea about how long is your file, right? So size will indicate its length. Okay, then protection is an attribute which controls who can do what sort of operation over the file. So if you are protecting a file, that means you are restricting the users to perform operations over the file. Now operations can be reading a file, writing to the file, or simply executing. So by protection, you are controlling these kind of operations done over the file. Time, date, and user identification is used for data protection, security, and usage monitoring. Now, information about files are kept in directory structure. Remember, the files are the lowest level up. Assume a tree structure where all of the data lies at the leaf node, right? And we just have um, sub nodes in between, right? So these sub nodes are actually the directory, okay, and the leaf node is the exact file. So information about the file is kept in directory structure. Where you can find this file, you'll have to look into the directory. Then you can locate that file. And that is maintained on the disk. See, directory structure is maintained on the disk. You'll come to know about this. Let us see file operations. A file is an abstract data type. We can have various operations over the file, such as creating a file, writing to the file, reading from the file, repositioning within the file. So here we are relocating the header, we are repositioning the header within the file. Then we can even perform deleting operation in case if we are not if we don't want to use a particular file, we are not in need of certain file, we can simply delete those files. Next operation is truncate operation. Then OpenFI is an operation that searches the directory structure on the disk for entry FI. See, here we are passing a parameter FI. So FI is the file name associated with it. If you are performing an open operation on a particular file named as FI, so this makes the operating system to search the directory structure on the disk for a particular entry of the file FI and move the content of this entry to memory, that is main memory. If we perform close operation over the same file, then the content of this file, which is now residing in the main memory, is put back to the directory structure on the disk. The content is then taken out of the main memory and it is placed back over the disk. Let us see open files. In order to open files and manage open files, we need several pieces of information, such as file pointers. Now these are the pointers to last read or write location per process that has the file open. So we need file pointer that will point to the last read location within the file, and this is per process. Next is file open count. This will give you the number of times a file is open. This will give you the counter, how many times a particular file is open, to allow removal of data from open file table when last processes closes it. Obviously the processes are in need to access certain files. See, files are again a resource which is needed by the process to perform their execution, to complete their execution. Okay, so obviously files will be needed by the processes. So here open file count will indicate the number of times a file is open, and once it is open, the entry is made in the open file table. This will indicate which was the process who closes this particular file last time, this recently closed. Okay, disk location of a file. Next information we require here is disk location of the file. Where does this file is located over the disk, over the hard disk? So cache of data access information is needed here. Then comes access rights. This is per process access mode of information. Access right is per process access mode information. See, we cannot give all of the access, all of the operations to be carried out over the file by all of the processes. We have to make some restriction. Only certain group of processes can execute it. Only certain group of processes can write into the file. Okay, and certain group of processes can only view the file content. So this is done by giving access rights to the processes. I hope you have understood this point. Open file locking is provided by some operating systems and file systems. Now this open file locking mediates access to a file. When you are performing a lock over a file, so it mediates access to a file. Now there are two types of locking. One is mandatory, the other one is advisory. Mandatory locking. In mandatory locking, access is denied depending on locks held and requested. Whereas in advisory locking, processes can find status of locks and decide what to do. Now here are the file types, names and their extensions. So you can see this table here. It includes file type. If it is executable, the usual extension is .exe, .com, .bin, right? And the function is ready to run machine language programming. In case of object, file type is object, the execution is either .o or obj, which indicates that it is compiled and machine language, but it is not linked yet for execution. Then there is source code, which you may be knowing, like Java or .cc or CPP or ASM for assembly language programs. Then you have batch files, like extension is sh or BAT. These are the commands to the command interpreter. For text file you have txt or doc. For word file you have wp, and so on. You can have a look at this table and get to know about more. Let us now see access methods. A file can be accessed sequentially or directly. In case you're performing a sequential access, these are the sequence of operations carried out over the file. First, we'll be needing read next, then a write next operation. We will be resetting the pointer and no read after the last write. Okay. Whereas in case of direct access, we will be reading. See, in case of sequential access, your file pointer matters a lot. Wherever the file pointer is pointing, you can read from that location to the next location, and you are reading location by location, one at a time. Okay, this is sequential access. So that's why we have taken here a pointer next. When we are performing read, so we'll be performing read next. So read the next location, then write on over the next location. We can even have a reset. Okay, so reset will take back the pointer to the starting location within the file. Okay, now in case of direct access, we'll be performing a read operation on n, when n is the relative block number. So within a file, we will be jumping to a relative block number and will perform read from there. So this is direct access. Okay, we are not reading location by location. We are simply going to one particular block and we are performing read operation from there. Similarly, write operation can be carried out in the same manner. Then we can position to n. We can again go back to a different relative block number, and then from there you can perform read next and write next. Okay, and then we can rewrite n. Now here is the diagram that shows sequential file access. So here we have the beginning and ending, that is the beginning mark and the ending mark of the file, and this is the current position, that is the current pointer we are having here. So if the current pointer is here, we can perform read next, so that reading will take place from here till the end, okay, in this direction. If we reposition the pointer, so it will, if we reset the pointer, it will go back to the beginning position here, and then we can continue. So this is actually a sequential access. Now here is a simulation of sequential access on a direct access file. In case you are performing a direct access, see, sequential access on a direct access file. So if we are performing a reset in sequential access, how it is implemented, let us see. It is implemented using the current pointer. CP stands for current pointer. Current pointer will be initialized to 0 as soon as you perform reset in sequential access. When you perform read next operation, so wherever is your current pointer, it will be incremented. You will be performing read the current pointer, then current pointer will be incremented by 1. This is how read next operation is actually implemented for direct access. Similarly, write next can be implemented here using write the current pointer, then current pointer is incremented by 1. Now here is an example of indexed and relative files. See here, in case of indexed file, relative file is having the actual values, right? So in indexed file, you will be having all of the entries and their logical record number. Index file includes all of the entries and their logical record number. Looking at this index, we can switch to the direct location where the actual record can be found. We can find the actual record here. So if we look in the index file, the entry for Smith, we can see the logical record number, which take us to the relative file location. Now here is the directory structure. A directory is a collection of nodes containing information about all files. See here, directory includes information about all of the files. You can see these are the directories here, and here are the files F1, F2, F3, F4 till Fn. Now both the directory structure and file reside on the disk. See, as there is a limitation of RAM size, that is random access memory, we have limitation of it. So the directory structure, which helps you to get into the information about the files, this is kept over the disk, as well as the actual file reside on the disk. Now backup of these two structures are kept on magnetic tapes. A typical file system organization has been shown here. See, you have partitioned the memory into two partitions, where you have you have your disk 1, which is partitioned into two, partition A and partition 2. So this is how you can organize the file system. This is one way of organization. This is another way of organization. Whereas you are having disk 1, you can partition the disk into two parts. Okay. First is partition 1, second is partition 2, and each of these partition is having their own directories. See, this particular section is having their own directories and files, and your own directories and files. Whereas you can implement in this way also, having a common directory, and then you can partition it into C, like making two disks. Okay, but the directory is common, and then there comes the files. Now let us see what are the operations that can be performed on directories. You can search for a file. This is actually you are performing operation over the directory. If you are searching for a file, you are performing operation over the directory, because directory includes the information about a file. So you first need to search the entry in the directory. Then creating a file also is included into the directory. If a new file is created, that entry has to be retained in the directory structure. So this is again an operation associated with directories. Then list a directory. Just list out how many files are there in a particular directory. Then renaming a file is also doing some operation, because directory has to update its information about a file whose name is being changed. Then traverse the file system. So these are the operations that are performed on directory. Now here is the organizing, logically how you can organize directories to obtain efficiency. We can organize the directories. A directory organization is also an essential part, as it will take us to the efficiency, right? How quickly we are able to locate a particular file. That's why we are organizing the directories. First is efficiency. Efficiency means locating a file quickly. Second is naming. What conventions you are using so that the user is able to understand the content of the directory. Okay, so it should be convenient to the users. Such naming strategies should be utilized. Two users can have same names for different files, right? Two users can have same name for different files, and there is again a possibility that the same file can have several different names. Now here we can use grouping. Now, grouping is logical grouping of files by properties. For example, all Java programs, all game programs in one directory. You are just grouping them by their properties. Here we have single level directory, where a single directory is there for all users of the system. See, single directory having all of the entries, all of the types here, and then each type is having their own file, right? So, but in single directory for all users, there can be a naming problem, as many users may use the same name, right? And file name may face a conflict. Grouping is another problem here. Now to overcome this, we can go for two-level directory structure. This separates directory for each user. See, according to user, a master directory is made for the users, user 1, user 2, user 3, and so on, and then you are having user file directories and then the actual file. So here you have two-level directory structure, where the path name is essential. So from user 1, if you are going towards a particular directory, it will have this path sequence that leads to the final file. Okay, now it can have the same file name for different users. Now file name can be same for different users, but still we are using here two level directory, so it will never conflict here, since we are using the complete path here.